I know if you're here or not. Then, one by one, I ask you to come here and to start a presentation. And because we have very short time, when the person finishes presenting, the next person should already be here and ready to plug the computer. So like that, we don't lose time on calling, coming, and so on. Okay? And the time is strict, so after the time is out, when the time will be coming to an end, when you are at the 6th minute, I will show you that you have 1 minute. When you are at 7 minutes, I cut you and you cannot continue talking. Okay? Good. So please raise your hands if you're here. Andre Cheese, okay? Dave Mason, okay? Sebastian Jordan, yes. Pierre Laborde, yes. Again, Pierre Laborde, okay. Karsten Hartl, yes. Annick Fron, perfect. Dmitry Matveyev, yes. Domenico Cipriani, yes. And Wade Heller, perfect. Okay. Are you okay with this order, or do you want to change something?
I want to change because I have to leave a little bit later.
Okay. Can you be the first one?
Yes, I can be the first.
Perfect. Okay, so you can start connecting.
A little bit. I'm Domenico, and yesterday I was making some music with Faro. Tomorrow at the social event I will make more music with Faro and louder, I hope. And yesterday after my talk, Milton told me it would be nice to put some sounds in the animation, and yes, now we can. So we took some of the example Rosa. Yes, and again and again. Okay, so this was the first example, and it's very, very small, but basically there is this dirt single event that is an event that is sent to Super Dirt audio server of Super Collider, and you have a lot of parameter, and you put it where you want in the raw cell code when it's doing something, and it does something. This is the second example with some mouse action.
B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S.
Muy bien. This is the last example with the running cat. That's all.
So hello everybody, I'm Andrei from Think, also working on Gamera's toolkit. And there was a question about how to extend the debugger. So yeah, this is going to be a very short part about that. So like Doru said before, in GT we have a lot of extensions for the inspector. So this is just a simple query that finds all methods that define views for the inspector. So there is a long list, and if we look at how many there are, there should be a bit under 3,000 at least views, just views for different objects. But then, if we look at the debugger, maybe there are 5 or 6. So there is a big difference. And then why is it like that? Why is it that we create extensions, but we don't create debuggers? Something is a bit off there. So we are thinking to have a different way to extend the debugger in GT. And that is to this notion of moldable exceptions, because when you get a debugger, when an exception happens, that's one way. Of course, you can use it for development, but we have to start from somewhere. And this felt like a very easy way to do it. So for this, I'm going to use a very simple exception just so that we have something to play with. So this is a test. An example in our case, it computes some data, nothing else. It just returns some predefined thing, but it computes data. It has an assert, and then it returns. This assert tests that this data equals the data stored in this method. So this method stores some data. This assertion, all it does is execute this method, it gets the data, compares it with what we give it. That's it. So if you run the test, it's red. So now we can try to run into the debugger. So we get the debugger and we can proceed. And now we get this in the debugger. We still have the previous debugger, so we can still go and see what happens in the actual debugger. But because we got an exception, that exception can define debugging views and actions. that will automatically be shown in a custom debugger adapted to that exception. Just to show you, we can go back and inspect the exception. So this is the exception object, and the exception object has this view here. And if we do Alt-click to look at the implementation, it's just a normal view. Only difference is that it has this GT exception debugging view. So that's all it takes to transform a normal inspector view of an exception into a debugging view that you'll get during debugging. And this doesn't have to be limited only to views. It can also have actions that can happen there. So just as an example, this here says that I'm okay with the new version. So I want to compile the new obtained version as the expected version and continue execution. So let's say, look, this difference is okay for me. I don't need to fix anything. Now I will say, okay, I want to accept this. Now execution resumed and the test passed. And this method here has the new version of my data. So this is just a very simple exception with some views and actions that are shown by default when we are debugging. And just to show you very, very quickly how we use this in GT, I will just show you two cases. So here we have an object and there are some errors in the views. That's not good. So we're going to look at one error. So this error, for example, is, so I don't know what it is, so maybe I will rerun. So this reruns the debugger. I still didn't do this, I just want to do this live, so I will inspect the exception. And this exception doesn't have any view now. But now I can go, and this is the view that I added. So I will just remove this and remove this, and now save the method. And now, yeah, I got a new view here, but now it's not in the debugger yet live, so I'll have to redo the execution. So now if I rerun, I get this. So now I get the debugger telling me a view in the debugger telling me what the problem is. So it says the flow view created by my method return directly the view argument. So there I directly return a view. So this we don't allow when creating extensions. You have to return an empty view instead. So now, for example, I have here a refactoring that I can do that directly, let's select it, directly fixes. So it has this empty. I can fix, I can apply it, so now this has been fixed. So now I can even restart execution and update the inspector directly from the exception. And in this case, the error disappeared because this was an empty view. So right now I had an exception, I got that debugger, the exception had a domain-specific view that I could interact and perform some actions. And the final one is, for example, you see here there are some errors. So we have an assertion that verifies if there are errors while executing the views of an object, just so that we know. And that assertion, of course, has a custom debugger. So in this case, we get this. So this is just I could again go to the debugger if I want, look in the stack, see when it asserted what it asserted, like there it asserted something. Or I could just look at this and see, okay, there were these two views that had a problem. And I could select the view and I could see, for example, here, this is a view that failed because there were two exceptions in the list of elements. So it's a different way to, at least when we have exceptions, interact with the environment and try to see what to do. And we try to really reduce the cost of extending the debugger and try this mechanism, as we'll see if this will work. And also I think this will be good because it will make it possible to create more domain-specific exceptions. And we'll have an incentive to do, instead of always just doing error signal, and that's it. Yeah, that's all. Thank you.
So this was a particularly brilliant order for this to happen, because I'm going to be talking about something very close to what Andre was just talking about. Allow accessory, yes. And let's just full screen this. Okay, so we all do test-driven development, I'm certain. But when you're doing test-driven development, you often write some code and you have in your head what the result's going to be, but it's a pain to write. Self-assert, whatever your expression is, equals, and type the thing. It's not huge friction, but it's a bit of friction. So I came across this interesting web blog that somebody wrote about how they had this REPL that they kind of automatically inserted values. And I was mentioning this to Steph, and he was commenting that what he does is he just puts self-assert blah equals garbage. and then nil is what I often use. And then once it fails, then you cut and paste what it said. You look at it and say, yeah, that's what I wanted, and you paste it in. This doesn't take long, but it takes like 30 seconds. So this is what a typical exception might look like, and a typical test. And when we run it, it's green and life is good. But when I wrote this, what I really wanted to do was this. I just wanted to say, try this, and I'll look at the result, and if it's what I expected. So let's try actually running this test. So we run the test, and it evaluated and inserted the value that I got and highlighted it. So if I realized, oh no, I actually wanted 43, then I could just move the arrow or the cursor, change it, and then there's a button here that says save and go. And so now it saved that, and we're on to the next one, which I also typed in. And yeah, that's what I expected there too. And we're done. It's a bug, not in my code. It's a bug somewhere, probably in ESUG, that it highlights it in red. So this is, and let's just do another quick example. So add another, and I don't have, the cursor is too small. So let's just, so add test 3, whatever, just, I don't care. Self, try, and try, colon, whoops. And let's just say, quote, A, B, C, D, B, 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 copy from, and I don't want to have to figure out which are actually the values that I want, so copy from 2 to 5. So let's just save that, and now I want to run it. And oh, it's because so I did care, didn't I? You were right. Save. Okay, so there's test 3. I run it, and oh, it's BCDS. Yeah, that makes sense. Okay, and we're good. So that's all there is to it. It will save you moments every time you write some code, but they were important moments because it takes away that breaking your train of thought. And obviously, you're not going to use this for all of your tests. For a lot of your tests, you're going to think about exactly what you're going to produce as a result. So Andre just explained why you want to use Glamorous Toolkit to do this, but I'm going to show you, because Stephen and Valentine yesterday kind of showed us that it is easy-ish, maybe not quite as easy as in Glamorous Toolkit, but easy-ish to add debugger stuff. So this is the code that I came up with much help from them, so great thanks. So this is all I had to do this. So I actually made this as a custom debugger, and so this is the debugger, and it is a subclass of STDebugger. A few things I had to do. The assertion value is very trivial. All it does is just stores the result. And the exception for, I added to test assert. So I added an exception that just holds the value. I added try. Try is very trivial. It just raises the exception. And yeah, so I had to add this class. Really, there was only, these two methods were things I had to do because I wanted to add the button. If I didn't want the button, I wouldn't need those. I'd need just this one. And I just copied this from some existing, from the superclass and added one thing to it. And again, for the buttons, I needed these two other classes. So if I didn't want the button, it would have been like 3 methods that I had to define to get this. So again, not as smooth and clean as Glamorous Toolkit, but still not very painful. So I did not get a chance to put this on GitHub yet, but I will put it up very shortly. So if you look under DV Mason, there'll be a repository for it, and called something like assert value. And everybody that I've showed this to on the INRIA team has said yes. So I suspect it will appear in or some version, cleaned up version probably, will appear in Pharo very soon. Thank you.
Hello, everyone. Today I'm going to show a little project that I did. It's a genetic algorithm to solve the traveling salesman problem. I am going to quickly explain what is the traveling salesman problem for the ones that don't know. It's basically when you have like different cities or points, like for example here, and you need to traverse all the cities only once, and you need to start and end in the same city. For example, we can have this example of the farmer. He has a farm and he needs to go to the school, to the gym, yes, to the movies, and also to another farm. And for example, he can do it like that, like that, like that, like that, like that, or also he could do it like this, and there's a lot of different ways. The purpose of this is to minimize the total distance that is traversed. And for example, when we have like 5 or 6 points, it's easy to do it by hand, but when we have like a bigger cities or points, it's difficult. So I'm not going to explain what the genetic algo, because Alex did a cool presentation yesterday and he already explained it for me, but I will show you my implementation of it. So, well, as you can see, we have a chromosome class in which you need to define the crossing method and the mutation, and also a class side method that is a generate random individual. So like I have extended like the traveling salesman chromosome, and for example, for generated, well, for this example, I assume that the graph, all the nodes are connected with all the nodes for simplification. So easy, well, we start in the city that is B, because we are going to say, okay, A is the initial city. Then we are going to repeat for the number of cities -1. We are going to add C, D, E, etc. until we have like the number of cities, which in this case is 10. And then we are going to random shuffle to be like random. And then we are going to add the initial city at the beginning and at the end. Like that we know like this is a correct path because all nodes are connected with all. Then we need to define the cross function. In this case, I'm going to show you here. So it's a little complicated, but not that much. So basically, we take the initial city, then we make a copy of the crossing chromosome 1 and the other one. And then this loop is for finding the limit. So we're going to, for example, we have like one chromosome that is like the list of cities. So we need to randomly find a range. We're going to copy that range into the child, and then we are going to add the other cities from the other chromosome. So here we find the range with some conditions to be like more logical. Then we start to add in the other cities from the other chromosome. We can say one is the father, one is the mother. Then we add the initial cities at the beginning and the end, and then we return a new chromosome. This is the crossing. And then for the mutation, we basically only swap a chromosome in a random position. That is not the initial city, because that is a condition of the problem. Well, with this, I think it's like enough. And then we have like my implementation of the simple algorithm that I'm going to show you is not so difficult. So basically, we start with the run. We generate a random population. We start with 0 generations. It does not converge at the beginning. Then we evolve 1 generation. We check if it converges. And then when it will converge, we return the best fit chromosome. To evolve 1 generation, basically, we need to first create an ordered collection. We determine the number of crosses, because we say that not all the chromosomes that are going to cross, there are somebody that they are not going to find a partner, they're going to die alone, I don't know. Then we use this technique to find to select the crossing probability, like the chromosomes that are more adapted to the environment, they have more probabilities to be chosen. So for doing this random selection based on probability, we use this technique that is the roulette wheel selection. Then we select the father, the mother randomly, but there is the probability already. So we choose the child 1, child 2, we cross them, we mutate them, then we add them into the, Then we add it to the descendant list, and then we repeat this cycle until the end of the crosses, and then we add the population. We reduce the population. Reducing the population is to kill the less fit. And then we do it. And that is basically that's it. And also the roulette wheel selection is an algorithm, but you can actually look at that in Wikipedia. And I will show you how it runs. So we have a simple genetic algorithm, new run. Boom, we run. Takes some time, and then it returns the best fit chromosome. In this case, we see that the total distance, so the distance for traveling all the cities and coming back is 20. And then we have this like thing. Well, this is kind of boring because I don't understand what is this. So also we can make a visualization, for example. And so we can, I did this presenter, and we open it, and boom, we have Russell. And then we click generate random population. Boom. And we see a random individual of the population. So we can see here, the distance is 40, the fitness function is 20, the fitness function is something technical, not important now, and this is the zero generation. Has converged, false, okay. So we can evolve one generation, so we can see that the distance normally is improving. Here we select a random individual of the population, and then we can see eventually we are reducing the distance. And then, okay, the conversion is true, so we say that this is the best individual that was found. Also, we can reset. And if you don't want to do it by hand, you can do evolve until the end. Boom, it converges, and it also returns the individual with 20. And also, you can inspect, you have the object, and you can see, okay, I have this, I have my configurator. This is a little object that I created only to have like these configurations. For example, the crossing probability, mutation probability, convergence rate, the initial population size. The thing that I really like about the genetic algorithms is that you only need to define these functions, and then the algorithm by itself find you a good fit chromosome in which you don't need actually, you don't know the answer. So this gives you the answer for you. Thanks.
I am Pierre Laborde. I have two small projects, personal project to show to you. My first project is a NetAtmo PI implementation. In my home, I have this kind of IoT. It's sensors that provide to me the humidity and the temperature in my home and other things. I have some humidity problem in my home, and I need to do some analysis with all statistics. So, and I'm developing this implementation. NetAtmo is the brand of the constructor. So, what is interesting in this project? I using the Open Authentication 2 protocol. I don't know if you know that is it. Usually, this is used by web application to ask a source from an application to another application to access to data, and you need to confirm manually with your browser. Okay, I'm the browser, the provider of the data, and I validate the access. So usually this is used for web application, but I using in this application. This is a desktop application, so you can use if you want. So I need two information in this protocol: my client ID and my secret ID. You can get it from NetAtmo or other provider of IoT things. And I have an example in my project. Here I enter my client ID, or I do a dirty example, and a secret. And after I open automatically a browser with a little Zinc server launched on my Faro image to get the message and communicate with the provider. Here I have enter a dirty code. So I can show to you the initial procedure to authenticate your application to the provider, and after, when it's done, the protocol renew a token each 8 hours, I think, or 12 hours to re-authenticate automatically your application, and you don't need to re-enter your secret ID. So I just redo this this part without the screen to don't show my secret ID. So I enter my client ID, so the first step, okay, and after I enter my secret ID, my secret number, okay, and I press OK, and replug the screen. So the browser open automatically, okay, in the provider page. So I need to enter my mail and my password because I have an account. I click on connection, and I have a configuration. So that's Netatmo. Okay, I need to accede to this sensors. This is the protocol. Okay, I accept to the access. I written a little page to confirm the successful authentication. And now I go back to my Faro image and I have the session. If you look at this code, I have the session. Before the demonstration, my session was nil. Now my session is not nil and is live. I'm connected to the provider and I can get some requests. So I written some example to have illustration. So this is a live request from my home. Here you have the list of my device. This is my my room, my other room, etc., etc. You have the list of your device, and I can get all information in my home with my application. For example, I've made some graph with my humidity. So this is the last 7 days humidity in my home. You will see that I have big problem with humidity. And for example, another graph with the outdoor humidity as the indoor humidity. So this is very cool to manipulate my data with Faro and not only on my phone, because there is a phone app like other IoT device. So now I have implemented a model. This is simple. I get the device. I get the measure with a simple requester that begin, that end, and I build the rest chart after. So this is very very simple. So that's the first project. I have another project. Thank you. My second project is very very short.
I'm sorry. So
Oh,
now
yeah.
Pierre Laborde, and after him, Karsten Harper. Please.
I set up the scale. Okay. This is just a small project. The page is here. My passion is video game. I'm a collector of video game. I have a lot of video games, and I have an application in my phone to enter some games, to get the list, etc. But this application is only on my phone, and the only thing that I do is to export in a file, and that's all. So I developed a model to get some data and do some advanced requests for my collection, because when I know advanced things on my collection, I can do requests with the Faro environment to have my needs. So I have just an example for you. This is here. I written some example. I have just a script to import this famous file exported from my application in my phone. So this is my collection. I click OK, and now I can use basically the Faro IDE to explore my collection. So this is the application provides a free collection list, a wish list, a for sale list, and a need list. This is my need list. If I click on it, I can browse my collection. You will see here. And for example, I have some. I write in some quick request to. For example, I have only. I need to have in my collection what video games I have only the manual, the notice, because I have a lot of notice alone. This is completely stupid, but I have, and I have 6 only. So I can click on this notice. This is Mario Sports Mix notice on Nintendo Wii, and I have the detail here. This is just a manual. So it's cool for me to do some requests on my collection, or to explore my collection. For example, here this is all my video games. I can get, for example, Gran Turismo 5. and I have some details on my collection. Voilà, that's all. Thank you.
So, how many of you are using VisualWorks? A few, okay. So how many put your files in VisualWorks? No one. That's too less. So you will change your mind after that. Okay. A typical problem is if you have all your small code versioned in VisualWorks, but you don't have your files versioned. So you have no notion in VisualWorks if you use store of a complete versioning of your whole artifacts of all your code and DLLs and everything. So and with the web applications, you have a lot of files like JavaScript, bitmaps, icons, and everything. So it would be good, I think, if you have a version which has attached a top version of your project, and if you load it, if you merge it, if you compare it, then you get all artifacts compared, not only the smaller code. So basically, there is already a file support in VisualWorks, but this is just very, very basic. Most people even don't know it. So a couple of years ago, I changed that and made all the tooling for the file versioning, so that you can load the files with the Smalltalk code and publish changes, addition, deletions, and also merge deletions and everything. So the basic application I was working on, that we have, it's a former FAT client with which is transformed to the web. Still COBOL files in there, 800 HTML files, 700 icons, 500 Smalltalk server pages, Siren business intelligence files, JavaScript configuration, some special libraries, ActiveX, DLL, and everything. And if you just want to configure or compare versions, then it's very complicated if you just load the Smalltalk code and you have to manage all these other artifacts with a different versioning system. So we do everything in store, and just extended all the tooling for the basic support. So one important thing is you preserve the timestamps also. Because some of the management tools, you just download the files, you have the contents, but you don't preserve the file stems. You want to preserve those file stems also, that you can use the normal comparison tools, and then just browse versions. As you browse Smalltalk code, you can just have all this tooling which you usually have. I implemented originally already in 2009, and now with VisualWorks 9.2, there's an extra notion of the better merging algorithm, which also implements the notion of moving files. And this is a little bit of a problem if you move files or between packages. In the history, there was a problem. First, you get merged the additions. And after that, you get merged the deletions, and all the files were gone. So now he detects that this is actually a move, and doesn't just moves the file definition between the packages or the bundles, and not does not delete anything from your. So you go on the normal browser. You have all this tooling like add files from a directory, add a whole directory to your bundle, remove files from the bundle, compare files with a different version, compare with parent, everything you need, you see from the normal Smalltalk code, you also have with files. And for the external comparison, there's a basic comparison tool for the Smalltalk code in VisualWorks, but actually it's a little bit better if you use an external tool, because the VisualWorks tool only knows Smalltalk. So, and if you have some other languages like XML or something, it's better to use something else. Like, for example, here Beyond Compare we use. You can just plug in another tool, and it stores the external tool to compare all your files, which also does a parsing for XML and a lot of other languages. So this is, yeah, okay, this is just a comparison, like SSB files. And also if you merge, you have you see a lot of smaller code here. And also you see the files which we merged with their file names. And it looks like any normal merge object which you have in your merging tool from VisualWorks 2. You apply the additions of files, you can apply changes to files, and also, which is important, you can merge deletions of files. I said if you delete files in one version and merge this branch into your files get also be deleted so that they have the same contents of your directory as before, as was done with the patch you did. Okay, three-way merge is also supported by the external tools. I said if you just merge something and you have a conflict, then you open the three-way merge tool and it tries to figure out by guessing the file type and then try to do a line by line or a more or less intelligent three-way merge. Then you can just save, and if you close the tool, the tooling detects the change and will then say that it has to be published the next time. Okay, then file versions is quite similar like the method versions, and you see here in the lower pane, if it detects that the file is identical to the file version on your disk, then it marks it as with bold. So sometimes you can immediately see if it's the same or is not the same. Okay, that was the tooling. Thank you.
People were asking me whether I was still busy with fencing competition software. So the answer is yes. So just to get an idea, this is, let me go to, how's it? No. Okay, so, okay, so, so this is what a fencing competition looks like. You have on the top you have what we call scoring devices, which are kind of microprocessors with signal processing.
And it's used for the microphone.
Oh, sorry. Okay. So on the top you have scoring devices, which are microprocessors, which are connected to the computers. And we have also displays, and on top of that we have web results, and we can add WebSockets to these web results to get better experience to users. Well, to understand what is the complexity of this, typically in Milano for the last World Championships, you had 2 computers per piste, 64 pistes, and you have of course a lot of other computers in the central area. So actually it's a lot of electronics. So what I will show now is how you can serve results on your cell phones from the arena, knowing that the chronometer will be in the arena and not on your computer. So if I click on my link, you can see an example. Oh, sorry. No, I didn't connect, sorry. Okay. No. Okay, so now it should be connected. So with what I show you is what I was trying to achieve. This is oh how's it? Uh, okay. Yeah. So, oops. But now, how can I? Oh, I can paint. So this is typically what we have. We have the names, the pist. We have also. Oh, doesn't run. And we have the score, and we were able to have the score. We were able to have the chronometer running, and you see that it's very smooth. Although it comes from the arena, and then it goes back to my server, which is in Reims, and it was shooted in Nice, which is a different location. You have this is made using WebSockets and SVG, using Visualworks. I can have another sample, and in this, maybe I can play it again because. Yeah, because we didn't see the chronometer. Okay, so you can see that the seconds are very smooth, and you can see also the lights lit, because the lights are regulated with 100th of second, so it's regulation for fencing. And now the last example where I can show you that really it can be very fast. So here we can select the pist, and if I run this pist, you can see again that we are able to have up to the 10th of seconds in a remote application. Okay, thank you.
Okay, so I'm Dmitry Matveev from Intel Corporation. Just disclaimer, I'm not on behalf of Intel here. Intel is not doing any production-ready Smalltalk products here. And unfortunately, Smalltalk is not part of my daily job. However, Smalltalk is a very great asset to my toolbox to do things which I do at my daily job, so I can now explain it to you. So I will run a simple demo, which is written in C++. It is not about Smalltalk, but anyway, you will find it fun. So it is Faro online course. I downloaded it from YouTube, and it's Stefan explaining us some concepts of Faro. So what essentially it is doing, it is running a face analysis algorithm. And in the background, there is a couple of neural networks running in parallel together in an ensemble to make this face analytics done. So the algorithm itself is a gaze estimation, so it shows where a person is looking at. And if the person closes his eyes, it will also detect that. So it just shows the vector where the head is located. And if you have multiple heads in the picture, unfortunately in this video, I'm not sure if there are more like 7 heads at the same time. So if there's multiple heads, then it will show these vectors for multiple faces as well. So now the question, why and where we have Smalltalk here? So the answer is we don't have Smalltalk here, but the problem is that this pipeline is very complex for a programmer to understand. And the project which I will present on Thursday, the sequence, allows to predict the execution time and the performance of such pipeline for a platform which doesn't exist yet, or when it is not stable yet to run some real algorithm, but we know individual components performance, and we can already assess what will be the performance in there. So here is an example code, and if I evaluate it up to certain line number 12, we'll see how this pipeline looks like. It is oversimplification, so I omitted lots of details from that pipeline. So we have a video stream, which is feeding our pipeline. We have a face detector, which is a neural network. I skipped the pre-processing part, I skipped the post-processing part, because it is just a demo. Then we have a landmarks detection. So for every face we detect, we crop a region from the image, and we run a landmarks detection, we run a head pose estimation algorithm, and it all ends with the gaze determination vector itself, which draws this two arrows on the image. So it is oversimplification again. The real pipeline is more complex, it is more sophisticated, but what I want to show is how we can use Smalltalk here and how I personally use it for other use cases which we have to enable in Intel when we have the question like this. So I measured the execution time for every model on my local machine. Again, a disclaimer, it is not official performance information. I measured it under uncertain conditions, blah, 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 so never use it as a reference. But I have 4 networks running in my, the deep learning networks, running on my laptop. So I took their timings and I assembled a pipeline from them. So now I can run the simulation with a sequence, which is basically the two I will be presenting. And what I get is this simulation trace, where I can see that, well, our pipeline completes in nearly 10 milliseconds time, so it maintains the real-time properties because our stream is 30 FPS, so 30 FPS is roughly 33 milliseconds to complete. So, and we can see that from like 4 cores, actually my computer has 16 cores, and when I run these networks internally, they use up to 4 threads. So I can imagine that in fact I have 4 cores and every network has a single thread. So when I run it like this, I see that it is enough to run on a single core, and you can fit the real-time property. So now the time of experiments. I want to see if I want to how much I can achieve with that. So for example, if I want to run a 100 FPS stream, I run it, and I see that still the time fits because the pipeline latency is below 10 milliseconds, so it doesn't cause the delays, it doesn't cause the frame drops, and the frame drop is this number here. So I processed 49 frames during my simulation time, but there is 0 frame drops. Okay, can I get more from that? So for example, I want to produce a 200 FPS stream, so we're like increasing the throughput. If I do this, I can see that, well, there is nothing different. The pipeline performance is the same. It is still those 9 milliseconds, but I already drop in my frames because my source, which produces my pipeline with data, generates frames at a frequency which I cannot actually handle. So now it is fine-tuning for the algorithm. I'll start looking at what I can do here to improve it. So I have 4 execution resources. In fact, I use only 1. So there is a special execution policy which is called pipelining, which I can use in my demo so that I can see what effect it will make. So when I run pipelining here, I can see that, well, it didn't do anything here for some reason. Yeah, because we have frame drops. But if I will increase the number of streams for a bottleneck, the bottleneck is a phase detector. Here we can see its block here on the trace taken most of the time. So it will start working. So I can take it like that. FD streams equals to 2. So when I have this, I have increased my density. So I don't drop frames anymore. Sorry. And yeah, I can alter parameters and see how the pipeline performance changes after that. So the second part of the demo is the stable diffusion. You might know the algorithm. For those who don't know, it is generative AI, so you can enter a prompt and generate the image based on the prompt. It's just always risky because you never know what it generates on the screen. So my prompt is hot air balloon leaving an island in sea, photorealistic view from the top. So something like byte cover. So the idea here is the stable diffusion is a not very trivial network to optimize. And we've looked at that from that perspective, and it was another part which I will not present in detail, unfortunately, but it is still a fancy application of Smalltalk in our environment. So here is the UNet. It is a neural network which powers the stable diffusion inside. And my assignment was to understand whether there is any opportunity to optimize this network to run and to utilize all the hardware we have in our system. So I wrote a tiny compiler in Smalltalk, which was pretty cool, which first of all loaded the networks from the OpenVINO format. OpenVINO is our inference engine for Intel platforms. And then I ran some optimizations on this IR And you can see how progressively I kind of reducing the complexity of my problem, and I can kind of combine layers together based on their computational complexity to isolate it to the certain size where you can think of the problem in a smaller way. So I could define it as a pipeline like I did before for the face analytics algorithm. But I didn't find any like parallel paths there, so it was not used in the final solution, but it was fun. Yep. Thank you.
So yesterday I was shooting the breeze with a few of the PhD students here, and I was mentioning that I like to write brainfuck compilers when I'm bored, and they were, you know, they seemed to enjoy that idea, and I was mentioning a few things that I did. I wrote a JIT compiler in C once. I wrote one in the macro system of a Lisp language that would make, you know, that would just assemble like the Lisp expressions to make it like that, and so on. And then I realized, hey, I have a perfectly good virtual machine here that understands bytecodes, so why not write that? And so I did that yesterday. This is, actually, today, sorry. I have a little brainfuck compiler instance here. It has two views that are kind of important. The first one is compile, and the second one, the historical compiles. There are no historical compiles, so we don't care about that. It's a new instance. This is hello world in brainfuck. And so first I want to inspect it. And so if you look at the bytecode, this is what actually gets generated. But Pharo is helpful enough to decompile it for me so that it actually kind of looks like code, maybe. Though this is fine and all, but I don't know whether you trust me that this is actually hello world. So we're just going to call this, and this is the tape afterwards. If you look at this, it actually spit out hello world. Let's try this again. Let's clear the transcript and run this again, just to show that I'm not cheating. And the transcript shows hello world. So this actually does work. That's kind of neat. And then I thought about, okay, I've done better in that in the past, so let's try to do better in that here. So I figured that this is the same Hello World program, so we don't care about that. But there is a Tower of Hanoi's program in brainfuck, and I tried to compile that and run it. And if I'm just gonna not maximize this window for a second because this is gonna throw an error actually. It's going to try to compile, and the jumps are too big because it generates so much code that actually it can't jump from the beginning of the loop to the end of the loop and backwards. So the virtual machine doesn't like the code that I'm generating. So I figured, okay, I know how to optimize brainfuck code and optimize the compiler actually. So let's look at this little snippet here. So that's a loop, and all it does, it increments. If you know brainfuck, what that means is we're just going to clear the cell that's under the tape head. So instead of doing a loop here, we can say, well, I think it's enable optimizations, if I'm correct. And the loop disappeared. It just says put 0 at the cell, because that's what it does, essentially. We can also do the same thing for our little Hello World program, not be optimizing, so enable. Let's get the yeah. So if I do that, right here I have a few sections where I just over and over increment something. So I can just group that together, and instead of saying add 1 8 times, it says add 8. So these are little optimizations that it does, and it indeed does still run. So if we try to actually execute this with this little trick, then let's look at the transcript. There is hello world. So that's cool. But does that mean that we now can run the Towers of Hanoi? Fortunately, it does not. Still too big. Still too much bytecode. And that's where I stopped for now. If I get any further, which I doubt because I'm running out of steam, honestly, looking at bytecode, if I do get to a point where I can run the Towers of Hanoi, on Thursday I'll meet you again. that's all I have. Thank you.